Hi everybody, welcome to, I'm sorry, let me share my screen first. Karen, can you see my screen?
I can.
Okay, wonderful. Thank you. Hi everybody, welcome to Application Development Virtual Group Webinar. My name is Sarah Huang. I'm the co-leader of this virtual group. Today, Karin Wolok will present using graph databases to understand complexly connected data. Karin is the program manager for community development at Neo4j. She began her career in entertainment marketing, working with the likes of names like Eminem and Live Nation. She also launched a successful professional women's network in 2 major cities in the US, organized events for local data science meetup, and helped lead an ongoing hackathon to put machine learning in the hands of cancer biologists. That's pretty cool. This journey eventually led her
Yes.
to her. Yeah, I like it. To her current role where she's making connections in a company that helps make sense of connected data. We really appreciate Karen shares her knowledge with us on a Saturday night. Let me first take care of the housekeeping things of past community, then transfer screens over to Karen. Karen, did I pronounce your name right?
It's Karin, but it doesn't,
Karen.
people call me
Oh,
Karen too, so it doesn't really matter.
oh, okay, cool. I'm sorry. So past Summit 2019 this year has a new thing. It has like a learning pathway with a 75-minute general sessions scheduled in order. So to help you follow a pathway from start to finish, so that you can it's easier for you to master skills you need to level up your career. And also the Data Privacy Week has wrapped up, and thanks to everybody who attended the Data Privacy Week event, which is a partner uh, with the Redgate. The past marathon recordings right now are available for on-demand viewing. Redgate also released their latest white paper, which goes into detail about data privacy legislation around the world and the 10 steps you can take to be compliant worldwide. There's a modern migration tour 2019 that will come to a city near you. So it's by past Microsoft and Intel, they teamed up for a world tour of local events designed to give you the tools and tactics you need to get to your final destination, a modern data platform. So the end of service date for SQL Server 2008 is almost here, so in July. And whether you're interested in moving to an updated on-premise cloud or hybrid solution, they can help. The the next session in the past Facebook Live pop-up expert series will be hosted by Melody Zacchaeus and Zacharias, I think. Sorry, I forgot how to pronounce it. Wednesday on June 26th. Melody is a Microsoft MVP, past regional mentor for Canada and technology leader with over 28 years of experience in SQL Server and data architecture. And if you would like to attend PASS Summit 2019, please register for this event. And as a member of Application Development Virtual Group, which is our virtual group, you can save $150 of your registration fee. And our discount code is VGDISHX2H. When you register to use this code, then you get $150 off. Unfortunately, you can't combine this code with anything else to get further discount. And PASS Virtual Group has many webinars lined up in June and July. So from various virtual groups like cloud database and DBA fundamentals and data architect, business analytics, women in technology, etc. They have a bunch of them. As you may know already, PASS has many virtual groups in different fields as well as different languages. And as always, you are more than welcome to join our virtual group, which is application development, as along with other fields of your interest. These are the upcoming SQL Saturday events around the globe, and you can search SQL Saturday to get more detailed information. And PASS has a career center for job hunters as well as employers. You can get more information by going to PASS website and click on that career. And this is how you connect with the PASS, through either Facebook, Twitter, LinkedIn, or Instagram. And the PASS membership is completely free. If you are not signed up yet, and you please sign up. And if possible, go to PASS Summit. You will learn a lot from that event. And this is how you may ask questions during our session. You may either raise your hand, like this little thing here. Then I will unmute you so you can interact with Karin directly, or you can enter the questions in that little window, question window. I'll read the questions to Karin. Okay, that without further ado, I'm gonna transfer screen over to our speaker. By the way, this session is recorded, and I'll try to upload the recording by tomorrow. Then Karin will share the slides later on. I'll post it to our website.
Thank you, Sarah. Can you see my screen?
Yes.
Okay, great. And we have 1 hour, right?
Yes.
Okay.
We are flexible, so.
Okay, I'm not sure how long it's going to take me to go through all these slides. There's a lot of content to cover, but I'm going to try to
We
get
would
through
love to learn. So, if it takes longer than an hour, Yeah, go ahead.
Okay. Well, I'll do as much as I can, and we'll see how much we get through. So, hello everyone. Thank you for having me. So I'm going to go over Intro to Neo4j. It's Neo4j is a graph database. If you're not familiar with graph databases or haven't worked with them in the past, I personally think it's one of the coolest thing that I've seen in a long time, and I was introduced to it about 2 years ago. So I'll give you some intro about it today. So, whoops. So today I'm going to talk about why graphs. I'm going to talk about some of the use cases, the data model, how to query a graph, and then Neo4j in general. So why graphs? So just to give you a little bit of a background on what is a graph. So when I'm referring to a graph database, I'm not talking about charts. So graph, I'm talking about more like the mathematical definition of a graph, as in like graph theory. Graph theory kind of originated by this gentleman. His name was Leonhard Euler. He was a Swiss mathematician from the 1700s. And he had tackled this problem called the Seven Bridges of Königsberg in Königsberg, Germany. Now, in Königsberg, Germany, there was this small island surrounded by land masses. So there were different islands that were surrounded by land, just like in this picture. And there were bridges that connected these islands to the land masses. And the people of Königsberg, Germany were curious if it would be possible to cross each of these bridges once and only once, and cross each of them once and be able to get to the original starting point. So Leonard decided to tackle this problem. So what he did, oops, you can't actually see this. So what he did is he actually drew out this map in the shape of a graph. And this is where graph theory comes in. So he created nodes, literally dots, that represented the land masses, and then lines that represented the bridges between these land masses. Now, what this allowed him to do when he drew it out this way is it allowed him to take his pencil and actually trace the graph line by line to see if he was crossing over any of these lines again. And in this specific case, in the Seven Bridges of Königsberg, he found that it was not possible to cross over every bridge once and only once and get back to the original starting point. And if it is possible, he named it the Eulerian circuit. And this is kind of where the idea of graph theory came in. So what graph theory actually represents is nodes and relationships, so how things are connected to each other. And this is what I'm referring to when I am talking about graphs. So these are like connected data sets. So now, why graphs? Basically because everything in our world is connected. So people, places, events, companies, markets, countries and history, sciences, art, everything is connected. And you can always find things that are dependent on one another, things that fall into buckets with something else. So because our world actually is a graph, this is where graphs can be a pretty powerful tool when you're investigating connected data problems. Now, what is it with the relationships? So it's not just about these connected data, right? It's about how things are actually connected to each other. So the relationships between pieces of data having value. And this is something that's really important with Neo4j. So like understanding not just things that are connected, but how they are connected. And this is something that we really value when we're working on complex data problems. So there is a lot of business value in understanding data relationships. And I think that as graph databases are becoming more understood and adopted in terms of what they actually are and how you can utilize them in your application and where they bring value, I think that there's a lot of new problems that you're able to solve that you just weren't able to solve before. And I'll get into that a little bit more. But here are some like the standard use cases. You have like real-time recommendations, fraud detections, master data management, network and IT operations, identity and access management, graph-based search. If you heard of knowledge graphs, that's also another use case. PageRank is also a graph use case. I'll get more into some of the specific use cases in the data models shortly too. And here is like, there's, again, common use cases. People will use it for internal applications to actually manage their data, who has access into what. When you're thinking about what the shape of this data actually is, it looks like a graph. It doesn't look like tables. And graph-based search, identity and access management. So you have customer-facing applications and internal applications. Basically everything's connected, so there's a lot of different ways to use it. So let's talk about Neo4j. So Neo4j is a graph database. Now, what does this actually mean? This is actually it's a screenshot from our browser. Like this is like the UI for the developer browser, or like the Neo4j desktop. So this is what it actually looks like. It's not meant to be a visualization. I'll get into that. Even though it is visually friendly. It's easy to understand. But it basically allows you to model your data as a graph, store your data as a graph, and query your data as a graph. And I'll get a little bit more into that too. So in database technology, it's really important when you're working with databases, and I'm sure like you guys are pretty familiar with this. Every database has its strengths. And where graphs really shine is when your data is highly connected, when your data is complexly connected, when you want to know how things are connected to each other. Maybe you're looking for pathways in your data, shortest paths, or you're looking for patterns between pieces of data or behaviors, things like that. Or maybe your data is just highly connected and you want to understand this complex connections. That's when graph databases are really shine compared to other types of NoSQL or relational databases. Now, Neo4j is built with the property graph model. Now, what the property graph model is, it actually allows you to imagine if you go to a whiteboard and you're drawing out your initial data model, right, before you putting it into a relational database, you're going to draw it out in some cases as a graph. If you're drawing it as a graph, chances are it is a graph problem. Chances are, not guaranteed, because not everything is a graph problem. But if your data model looks like a graph problem, it might be a graph problem. Now, the cool thing is about Neo4j is you're actually able to store that data in the same way that you whiteboard it. So this is what the data model looks like. Digging into it a little bit deeper, the property graph model components. So one is you have your nodes. These are the circles. Here are your nouns: person, place, thing, location, theme, machine, anything. It could be any type of data that is a noun. Now, those are the objects in the graph, and they can also have properties. So you can label these nodes. Now, between these nodes, you have relationships. Now, these relationships can have types. They can be types of relationships. They can be directional relationships. So you can have one person loves another person, lives with, whatever. You can have different kinds of relationships. They can have properties. They can have values. They can have geospatial information and date and time. So whenever you have data that's complexly connected and you really want to know these relationships in terms of how they are connected, and not just that they are connected. This is when relationships are first-class citizens. This is where it really comes in to be pretty valuable. Now, the other thing with Neo4j that's pretty interesting, aside from the property graph model, is the query language. So when you're working on graph problems and connected data problems, you're not going to want to use SQL. And I know it's kind of shocking, but SQL is just not built to understand how data is complexly connected. So there is a language, query language, that we have developed. It's an open language. There's a lot of other organizations that are using it, called Cypher. And Cypher is a declarative query language, and it's based off of ASCII art, so it's meant to look like what it actually represents. So in this case, you can see, you can see your person, here. So this in your parentheses here, these are your nodes, and then in your brackets with the caps and the arrow, that is your relationship, and then you have your other nodes in parentheses. So that's like this is a basic kind of overview of what the Cypher query language looks like. I'll get into it a little bit deeper shortly, where I'll actually give you some examples of what kind of queries you can actually do and how powerful this tool can actually be, or the language itself. Now, the other thing about Neo4j that's pretty powerful is when you're working with graph, like connected data sets, one of the problems with relational databases is when you have too many joins and you're making too many hops, every time you make a hop, you're indexing. So you're indexing every time you make a hop. And what that causes is it's very time consuming if you have a lot of joins, right? So if you're looking for something that's 5 hops out, your machine might never return anything for you. It's going to become really, really slow. So the way we have built Neo4j is actually built, the underlying architecture is meant to support this graph model. So kind of in a nutshell, if I was to summarize it, it's built with memory pointers. So the benefit of that is when you're querying complexly connected data, it doesn't sit on top of tables. You'll index one time when your initial starting point, and everything else is built with memory pointers. It allows you to traverse through the graph very quickly with having index-free adjacency. So whether you're doing 2 hops or 20 hops, you're looking something that's 20 connections deep, you're able to do that within like milliseconds. The traversal time stays pretty consistent rather than having to index all the time. So that's something that's very powerful when you're speaking about a native graph architecture. So Neo4j is a native graph database. So it stores the data in the shape of a graph to allow you to query the graph quickly without having to index in tables all the time. So that's something that's pretty powerful too. So I'm going to talk a little bit about the query language. This is actually this slide is a little bit old, I think, but the query language. So I'm going to give you some examples and show you how you can query a couple different data sets. But like, let's say we're looking for a basic pattern, right? You're looking for a movie that Tom Hanks acted in. Now, when you're looking at the query language, since it's based off of ASCII art and it's meant to look like what it actually represents, it's pretty intuitive. You can kind of see just by looking at the query what you're actually asking in the graph. You're looking for a movie that Tom Hanks acted in a movie and return the movies that Tom Hanks acted in. There's your label and your properties and your relationships. So here's like your basic query. That's what your query would look like, your full query. And this is what it would basically return to you, if given the data is in the database. So here is your query, and here is your graph. And in this case, you also have, this is a movie that Tom Hanks directed and also acted in. And since these relationships, you can actually have, in these relationships, you can have properties, as I mentioned before, and values. So these are like the different characters that he might have played in these different movies. Now, here's a comparison of query, of a SQL query versus Cypher. Now, SQL is kind of built to say, okay, give me this, right? You kind of have to know what you're looking for. With Cypher, you can be a little bit more ambiguous, and it's more based off of pattern matching because you don't always necessarily know what you're looking for in this connected database. So in this specific query here, you have your actor who acted in this is an undefined node, which means a movie, I don't care, but I'm also looking where this other person also acted in it, where the actor's name is Tom Hanks. Where a colleague acted in it. So I'm looking for a movie that Tom Hanks acted in, and also had a colleague that acted in this movie with Tom Hanks. So this is the difference in comparison. This is what your database would give you if you ran this query. And as you can see, I mean, the data is getting pretty complex very, very quickly. So I think, you know, you can see some of the power in it too, just based off of this, but there is a lot more you could do with Cypher, which gets pretty amazing. So this is a query where you're looking for the most prolific actors in the filmography, so people who have been in the most movies. So a person who acted in a movie, and then collect the titles and look for it in descending order, and limit up to 10 movies. And then, you know, Neo4j can give you subgraphs as a return subgraph or a table, because a lot of other, you know, when you're putting it in with other data or with other applications and stuff, a lot of times you have to return tables. You can do either. So getting data into Neo4j, there's a lot of, I'm not going to dig too deeply into this because we have a lot of content about this online and there's a lot of other things to cover. But there's a lot of really easy ways to be able to move from relational databases into Neo4j if you wanted to play around with, you know, your connected data queries. So the impact of graphs. So I'm going to talk a little bit about use cases and how graphs are actually being used in the world. It's kind of interesting because there are a lot of companies that are using graph databases. And I think because it's so different from most relational databases, it's kind of something it's very hard sometimes to kind of grasp your mind around, like, what is this? When would I use this? How is this valuable? And then when you find out that over 75% of the top Fortune 200 companies are using Neo4j for something, you're like, wow, okay, that's how I felt. I was like, I didn't even know this existed. But there's a lot of companies that are using it. So you have like the Microsofts of the world and NASA and Apple and United Airlines and Target and HP and Cisco. I mean, the list is just insane on how many organizations are using Neo4j for different graph-related problems. I think that one of the most interesting things about my job working with the Neo4j community is hearing about all the different ways that people use graphs, because sometimes you don't even think about the capabilities of what someone has the ability to do with their data. They know it better than they do. And when they start envisioning about all the possibilities of understanding this complex connection in their data, I think it really starts to open up doors, and there's some pretty interesting use cases. So I'm going to talk about some people who are using it for graphs for good. So I'm not sure if you guys are familiar with the Panama Papers or not. So the Panama Papers was one of the largest data leaks in history. There was an organization called Appleby, I think it's called Appleby or Appleby. It's a law firm in the Caribbean areas, and they had a huge data leak of all this basically emails and company organizations, like, and it basically exposed a lot of very well-known people that they were hiding kind of money under shell companies in order to avoid taxes. So they were like kind of tax havens in Caribbean countries, which started in Panama, was a pretty large one. Now, in order to be able to investigate this data, it's a lot of very unstructured, messy data. And with graphs, you do need to have nice, clean data. But the ICIJ, which is an organization of investigative journalists, decided to tackle this problem. They created an application to allow journalists to be able to go in and see how all these people were related to each other and how all these different shell companies were connected to these people and who was hiding under what kind of shell company. They created this kind of platform to allow the investigative journalists to kind of tackle this problem, which is pretty cool. And the Panama Papers story, I mean, if you haven't heard about it, you can read about it. It's pretty crazy. It exposed a lot of people. I think like the Prime Minister of Iceland or something had to resign. It's crazy. And there's also the Paradise Papers, which happened about a year and so ago, and the West Africa leaks. There was some of the largest data leaks in history. So this is kind of like the amount of data that the Panama Papers had compared to other data leaks. So the ICIJ data model, this is kind of what it looked like. So you had your officers and like intermediary, and then you have like the entities, the companies, and the addresses that these companies were registered as. So what the ICIJ did for these journalists that were tackling this problem, there was about 400 journalists that were working on tackling the Panama Papers data leak. So because the journalists were not programmers and they're not able to just write cipher queries, the ICIJ they cleaned data, put the data into Neo4j, and then put a visualization on top of Neo4j. The visualization is called Link Curious. And this allowed journalists to kind of just click around and do visual investigation to see who was connected to what and how all these people are related to each other and who's hiding what money where, which is pretty powerful. The cipher query language definitely allows you to do a lot of this stuff in a very kind of more automated manner. It's very powerful in terms of that sense, but it definitely helps to have visualization like this. There's all kinds of visualizations that you can put on top of your graph model, really depending on what it is that you're trying to understand from the data would depend on what kind of visualization you want to use. But this is an example of visualization. You can go to the ICIJ website. You can actually, and we also have on our site too, if you actually wanted to play around with the data in Neo4j and try to explore and maybe you can uncover something, you can actually do that too on our site too. So this is where the interactive visualization comes in. This is pulled from the ICIJ site, and it shows you the different public figures and how they kind of discovered that all these people were hiding shell companies and what they actually discovered about them. Cancer code with graphs. This is actually how I first learned about Neo4j, the data science project where I was working to put machine learning in the hands of cancer biologists with we had like 50 volunteers for the Cognoma project. And the guy who was leading the research, who is a postdoc from University of Pennsylvania, his name is Daniel Himmelstein. He uses Neo4j for his genetic/cancer research. And if you are interested in that type of data, he's got a website. It's het.io, het.io, where you can actually play around with a lot of like pre-existing like historical data and kind of see the connections between different types of illnesses and genetic patterns and stuff like that. But here's like one example of an organization that does cancer research. There's a lot of these types of use cases. Cancer and genetics are definitely a big connected data problem. So here's some disruption with graphs. So in machine learning, there is a lot of machine learning. When you're thinking about machine learning as a concept, a lot of it looks like graphs. And it's interesting because there's still a lot of machine learning engineers that aren't really using graphs yet. I personally think that it might be because they might not know the power of it, because it can be a powerful tool if it's used properly. Actually, I don't know if you guys are Spark users at all, but in Spark 3.0, there's going to be a new library coming out called Spark Graph. You'll actually be able to run cipher queries on top of your Spark data frames. And we're also putting out an open source tool called Morpheus that allows you to pull the data from Spark and put it into Neo4j if you wanted to run more graph queries. Since if you're running Cipher on top of your Spark data frames, the performance is still not going to be as powerful as if the data is stored and modeled natively, as I mentioned before, because like not having the index like sitting on top of tables, it still kind of eats the performance because you're doing a lot of hops. So if you wanted to increase your performance and really do some serious graph queries on your Spark data, you can use Morpheus. You can pull the data into Neo4j. You can run graph algorithms, which I'll get into in a second, and then you can even return subgraphs and query those, and then you can pump all that stuff back into Spark. There's a lot of really interesting things that are happening around machine learning with graph databases. So knowledge graphs, I'm not sure if you guys are that familiar with it. I think this is personally one of my favorite use cases. We have, so NASA builds their knowledge graph with Neo4j, their lessons learned graph. It's basically like a collection. I think I might have a slide in here. So it's basically a collection of all the lessons that they've learned over the years, and being able to surface the right information at the right time. And it's really, really powerful. They've been working on it for a long time. And I think the chief knowledge architect at NASA was quoted saying that this knowledge graph that they put together had saved them 2 years of time on the Orion project and millions of dollars in taxpayer money, because they were able to avoid a really huge problem that could have potentially been a pretty big issue because of their knowledge graph, which is pretty amazing. So SQL to graph, I'm just kind of going to run through one example of a relational database and what it would look like if you moved it into a graph model. So this is the domain model. You walk to a whiteboard, and this is what you draw. Supply chain management, right? So you have the customer, supplier, and product, and their orders. Now, this is how they ended up building their data. So they went from this, and then they went into a relational database, and this is what it ended up looking like, which is really interesting because all these relationships that you have, everything turns into foreign keys and all this stuff, and it's just like, it's not really intuitive, right? So this is the Northwind data set. This is an example of like how they went from a relational database into Neo4j. So we're building the graph model here. So building the relationship in graph. So we're looking for an employee that sold an order, right? So first thing is you're gonna locate your foreign keys. Now these foreign keys become relationships. And because Neo4j, in Neo4j, you can have directed relationships. So you can make things go one direction. You can create two relationships where they go both directions. But in this case, you have a directional relationship. And with Cypher, you are able to query the graph backwards, if you will. Like you don't have to necessarily specify a direction, but you can if you want to. And then you have to drop the foreign keys, find the join tables, and the simple join tables become relationships, and then attributed join tables become relationships with properties. And that is what the graph model looks like, which is a lot more like their initial domain model of like the whiteboard data model that they had. Now here's some examples of queries in this specific use case. So here you are looking for a product. Product name is Chocolade. Now, you're looking for where an employee sold an order that includes Chocolade. Now, you're also looking for where the employee sold another order that includes another product. So the employee first name, product name, and then here's the query of what it would give you. So this is for cross-selling products. So products that go together in other orders, and what other things these people might have ordered if they ordered Chocolate. Here's a product recommendation query. And here is an example of a query. If you were looking for all the direct reports of a person, how many people they manage, up to 3 levels down, right? So think about like an organizational chart of a company, and you're looking to see who manages who, right? Up to 3 levels. It's not that much. Um, this is what it would look like in SQL, and this is what it would look like in Cypher. So, I mean, relational databases, they can handle relationships well. Relational databases were not built for that, right? So, and that's kind of why Neo4j exists and why it does so well with, highly connected data problems. Neo4j graph algorithms. This is kind of a way to do analytics. There's a lot of interesting insight you can find when you're modeling your graph data in the shape of a network. We're talking about complexly connected data. I'm talking about billions of nodes and trillions of relationships. There is a lot you can discover. If you're interested in this types of analytics of what you could do with these like supermassive connected networks, here's just some examples of like we have like a graph algorithms library, Euler. I think there's like 46 or 47 graph algorithms in there that you can play around with, including centrality and like you could find things like pivotal nodes, so nodes that are connected to clusters of connected data. It's pretty cool. So it's like path finding, community detection, and centrality. So these are some of the graph algorithms that we have in the Euler app. If you're interested in this type of stuff, we do have it just came out, an O'Reilly book on graph algorithms, which I'll share a link for, where you can download it for free on our site if you are interested in something. What I personally do for Neo4j is I manage our user community. So I work with the developer relations team. Our job is to make sure that people can learn Neo4j, right? So they know what it is, they know when it might make sense to explore it. Maybe they want to play around with it a little bit before they put their data into it because they're not really sure if it makes sense, or they still want to kind of understand it more. The online trainings, the meetups, the hackathons, all that stuff falls under me, my team, right? So my team is responsible for it, and I manage our global community. So the way I kind of say it is I do all the fun stuff like the meetups and the hackathons. It's really cool. We have an amazing community of people that do all kinds of really, really interesting stuff. We host an online meetup every week where we talk about, there's usually different kinds of use cases that people will talk about. So everything from like Game of Thrones data, running graph algorithms on Game of Thrones and trying to detect who's going to die, or there's recently we did one on Bitcoin transactions and being able to find patterns in money transactions with this like really, really cool visualization that's like 3D. It's a really cool 3D visualization called GraphXR. We did oh my God, there's so many. If you're interested in like seeing other people's use cases, because there are some really, really cool use cases. I think that some of my favorite use cases that I've heard of is, well, there's some that are they kind of just make sense, right? So you have things like a lot of airline companies will use, I think it's like 95% of the airline companies use Neo4j for flight routing. And if you think about a flight route, when you're looking at airline maps, it looks like a graph. So, the nodes are your airports, and the relationships that are directional, those are your flights, right? Those flights can have times and properties and, different types of relationships. Maybe they're connecting flights or whatever. So it's definitely a graphy problem. So I think that one I thought was pretty interesting, but it's obvious why you would use it. There's a lot, I don't know if I'm allowed to say like some of the larger companies and how they use Neo4j, but there's one humongous company that uses it for like network infrastructure management, where they have all these machines and the different locations and what they do and what they're dependent on. So if something goes down, maybe there's something that's dependent on it that's connected to something else that somebody else is working with. It's super highly connected when you're looking at network dependency maps, right? And I mean, I hear things that there's like, I heard this guy talking at a conference. He was talking about what they're working on is he works for a law firm. They have 1,500 new civic cases that come out every week. And what they do is they have all the arguments from those 1,500 cases, new cases every week, and what the case was, and all it's a big knowledge graph, kind of, right? And then when somebody is working on a problem that's similar to all these other cases, they can actually service a lot of these arguments and help the attorneys figure out what best to approach with, which I think is pretty interesting. Then you also have some very standard use cases like recommendation engines and fraud detection are really, really big. Like if you're talking about fraud detection, you might be looking for patterns in your data, right? Like similar to the Panama Papers, you're not necessarily looking for one transaction or two transactions. This person sent this, but it might be like if this person had this kind of pattern in their behavior, in addition to this other thing that you're looking for. It's like, you're looking for a fraud ring. It's distantly connected. So that's when it's like really, really powerful stuff. There is another example of a recommendation engine, which I can kind of show you. There's a really good blog post about some pretty basic queries and where they really come in powerful. So how do I get it? You can just download Neo4j. It pretty much runs like every other SQL database. Yeah, if you're interested in getting it, this is where I would suggest to get started though. Like if you haven't used Neo4j before and you want to learn how to use it, this is where I would get started. So we have a sandbox. Sandbox is a place where you could just go on, you have pre-existing data sets, you don't have to download anything, you can just play around with pre-existing data sets, and there's guides that walk you through step by step with the full queries, telling you exactly what you're querying, what the data model looks like, all that kind of stuff. And it really kind of walks you through and shows you the capabilities of what you could do with graphs, just to really get you started without having to do all the groundwork yourself without knowing exactly what you're doing. I think that one of the things from when people are going from relational databases into graphs, it's almost like some of the problems that you didn't even think you'd be able to tackle, you're now able to tackle with graph databases, because relational databases literally just don't perform for highly connected queries. And that's where graphs kind of open up this whole new world of possibilities, which is pretty cool. So we do also have a developer getting started page. So this is all free and open on our site. Neo4j is open source, so you can download it, you can play around with it. We do have an enterprise version 2 as well. If you're interested, you can also get, you're also able to play around with Neo4j Enterprise. And so yeah, but we do also have, there's also a bunch of different ways to learn Neo4j. So we do have Graph Academy on our site where it'll walk you through learning Cypher. There's Cypher ref cards too if you need some help there. It kind of walks you in on the data model. Moving from a relational database to a graph database, I think it's one of the things I think is kind of interesting, because sometimes your initial data model is a graph model, but when you have to move it into a relational database, you almost have to translate it into this relational database world so it fits in this bubble, and then you have to kind of move it back. But there are a lot of ways, based on what you're trying to understand from your data, there are a lot of ways that you can move from, I mean, there are a lot of things that you should do, like to model this data appropriately in terms of all these possibilities, to see what you're capable of doing that you wouldn't be able to do with your SQL databases. One huge benefit is Neo4j is schema free, so that allows you a lot of flexibility to adjust things and make changes and stuff like that too. Here are some books. The Graph Databases book from O'Reilly book, that's definitely worth getting. It's a great place to start. It really breaks down a lot of the basics of graph databases. The O'Reilly book, the Graph Algorithms O'Reilly book, just came out like a couple months ago. month or two ago, something like that. Oh, actually, April 15th is when it came out, so that was like a month and a half ago. So that's definitely a really good one if you're interested in analytics and like all this complexly connected data stuff. And I mean, there's a bunch of books if you go to neo4j.com/books. If you are a full stack developer, grandstack.io is also a nice place to start. You can build full stack applications using GraphQL, React, Apollo, and Neo4j. This project is led by one of my team members, my colleagues, Will Lyon, who leads the Grandstack project. I will show you one other thing too, because I think that there is an interesting blog post that I really like about recommendation engines that that I found that really kind of shows the power of graph databases, and it shows a little bit about the query language too. So these guys they wrote a blog post about the recommendation algorithms that they built for video games. There is a lot you can do. This is kind of the very, very basics. So this is where it talks about the nodes and the relationships. And here is an example of a query, a cipher query where you're looking for a company, right? So in your nodes are in your parentheses here. You're looking for a company that develops a game, right? So you have a company that develops a game where the company also publishes a game, where the company is Electronic Arts, and then you're returning that. And then here, and this is what it shows you. So it's able to show you all the games that Electronic Arts publishes and develops. And this is just such a short, simple query, which I think is really nice. Here is another example. I really like this one because I think it shows the power of like the language and modeling your data as a graph. So here in the yellow, you have two different video games. So this is Fallout 3, and then on this side you have Borderlands 2. And in the blue nodes here, you might have, I don't know, the consoles that it's played on. And then in green, you have these themes of these games, right? So you have zombies and war and pirates. Now, these relationships are first-class citizens, right? As I mentioned before, so you can put values in there. So these could be weighted relationships. So you can have a lot of zombies and a little bit of dragons or whatever. Now, in the red nodes can represent like how the game is actually played. Is it played multiple player? Are you playing online? Is it a social game? Is it first person? Are you playing with a joystick or a mouse? So these are all the different characteristics of these yellow nodes of these games, right? Now, if you want to say, what do these two games have in common? What are their shared characteristics? You have a user that likes both of these games, and you want to just understand what these two games have in common. You can write this query. Now, if you're imagining writing this in SQL, this is why where Cypher like really, really shines. This is what your Cypher query would look like for this. Now, with all these different relationships and all these different nodes, in SQL it would be like a nightmare. Just thinking about it is like giving me a migraine. You know, here you have match a game that has a characteristic. Here there's an undefined relationship. So any relationship, any direction, I just want to know what they have in common. And then you're making the comparison of the two games. And the cool thing is, I mean, you can even put like *6 in this relationship here if you wanted to look like 6 hops out or something like that, where this is where like it kind of, I think that this example kind of really shows just like a simplistic way of like where graphs can really shine and where they can really be valuable. But yeah, so most of it is just like your complexly connected data. It really is about kind of what is the shape of your data. If the shape of your data is tables, then you probably should use a table-shaped database. And if your data is in the shape of a graph, then that's maybe it's a good opportunity to explore a graph database as an option. So yeah, so I think that's it. I think that pretty much covers it.
That's great. Yeah, that you did a really great job explaining it. I think it's very easy for me to pick it up. Thank you so much, Karin. Um,
Yeah, I think it's like
the-
it's hard to understand because it's like it's so different from anything that you've used. You know, like there's been times where I've tried to explain Neo4j to people and they're like, "Oh, it's visualization," and I'm like, "No, but it stores it like that." I'm like, that's the power of it, right? So like you can do 12 hops to see like how these people are distantly connected and patterns and all this stuff without having to index each time. It's powerful. Um, I don't know. When I learned about it, I remember I heard of a graph database a year before I actually understood what it was, and I was way off on what it actually was. Um, yeah, there's another really cool recommendation example in here too. So this is another one that somebody wrote a blog post about this one, um, which I thought was pretty interesting too. So like this is like a workout video recommendation. So here, oh man, so you have a lot in here. So here you have in the yellow, these are your users. In the blue, you have like different workout videos. In the purple, you have the different body parts that you're working out. In the red are they're like clusters of body parts. I don't know what else to call it. That's like a better word, like your upper or lower body. In the green over here, you have the themes of the workout videos, right? So it's like wellness or get healthy or get fit. And then in pink over here, you have beginner and advanced level. Now, what you have in this graph that I think is kind of interesting is down here you have asthma. So you have two users that have asthma, right? Now, since these relationships can be weighted, and Ben could have really bad asthma, Kevin could have not bad asthma at all, and all of these workout videos are all limited by asthma. And again, weights, you can also take the weights into account too. But it's a pretty simple query to be able to say, okay, find me all the workout videos for Ben, that are going to be least limiting to his asthma, that's going to work out his legs and his core, that's going to be beginner level in the get healthy category, like those type of things. um, like this is what the data model looks like. It's complexly connected, right? So yeah.
yeah, there's a question for you. Did you mention there's a free download of the
Algorithms, yeah.
algorithm, ebook? Is that ebook?
Yeah. Uh, yes, so it's the digital electronic book. Yeah. So you can go online. If you go to neo4j.com/books, you can download both the graph databases book and the graph algorithms book for free. Um,
Cool.
yeah.
I'm gonna. I typed for
Oh,
those.
oh, I don't have
Yeah,
the chat open, so I don't.
it's okay. I typed in our chat window. You post those like neo4j.com sandbox and
Yeah, the sandbox.
Neo4j, yeah, developer got started, and also Neo4j download. I put
Yeah.
and as well as the Neo4j books. So yeah, if any of you guys need that, then yeah, you can just go to this uh, question window, the chat window to get the links, so you don't have to type. Um,
Uh, yeah, we did this event earlier this year to celebrate Leonard Euler, the mathematician I was telling you about that invented graph theory. We wanted to celebrate him, his birthday, even though he passed away 300 years ago. So we did events with our community all over the world. So this is one of my projects. So I was saying I do all the fun stuff. So I was like, we did events like literally birthday parties with our
nice.
community all over the world. We had events everywhere, and there was like 6 continents. There was 60 plus events, and then so I had my colleague build this for me. Actually, the guy who runs the Grand Stack stuff, and people had listed all like their events and the different cities that they hosted it. Um, and then people could register for these events. And the cool part about it is what we actually did is we had a registration link where all our attendees could register online for which event that they went to. I know this looks like a hairball. That's the visualization that we ended up using, but here's an example of the browser. So like the sandbox is a great place to start because you don't have to really know much, but so I'm not going to write a query for this. I'm just going to kind of like hop around. So you have like, it takes a second to load because, it's, let's see. So here are the different events. So these events are like the different places, the different cities where people hosted a global graph celebration day, a birthday party for Leonard Euler. And this is my city. And these are the users. That's me. This is me. Hello. And then, I'm able to see like, what do I have in common with all these other users? This is actually what the Neo4j browser looks like, if you're curious. But it's really fun to play with and it's super addicting. So if you haven't gotten into it yet, I'm going to warn you, like there is this area where you fall into the graph epiphany and then you can't get out. You see everything is a graph from then on. You just like think about all the connections. So
Okay, we got another question for you.
yeah.
Can you demo a little bit how to connect to a relational database
I'm not going to be able to demo it only because I
to
am
get a
not
graph?
like I'm not a strong engineer. Like I learned about Neo4j kind of accidentally. I fell into technology like 3 years ago. And while I know the basics, I can't actually do demos, but there is a ton of resources online. So I think it's like if you go to youtube.com, Neo4j. So you're saying you're looking specifically for how to move from relational to Neo4j?
I
That was
guess
just one of our.
her question is, can you, well, yeah, she wanted to know like how to connect to the relational database to get the graph.
Okay, so like how to move from a relational database into a graph database, right? Because
Um,
like they're both databases, so like you'd be storing your data um, as a graph. So
let,
there's
let give me a second. Let me unmute her and see if.
okay.
Hey Rose, I'm gonna unmute you
Hi.
so that. Yeah.
Okay, thank you.
Oops, sorry.
Hi,
Hi.
hi.
Oh, your things. Rose, can you talk? Hey Rose, did I mute you or you self-muted?
Can you hear me?
Yes,
Yes.
yes.
Oh, cool. Yeah. I just don't know because I think will be very useful if we can use this tool, connect to any database we're using and see their relations. If we can connect to our relational database we're using, any database like SQL Server or Teradata, and can we show their graphs?
Yeah, so that's an interesting question. So one of the things I think with graph databases is that if you put graphs on top of tables, the performance can really lag. So generally, what people will do is they will put the data that they want to understand how is connected, like they will move completely from a relational database to a graph. If or with whatever data is relevant for them to understand how it's connected. But that's generally what will happen. We have a lot of resources online. I can't dig in too deeply into it because like I can't demo anything because I am not one of our engineers.
Okay.
But there's
Mm-hmm.
a lot of resources online. The other thing too is we also have a community site. So it's community.neo4j.com. So if you have specific questions that you want to answer, that like you're not getting any of these resources online or not helping you figure out what you want to do, you can go to the Neo4j community and you can ask here. We have a newbies section here too. We have a Neo4j newbie section.
Okay, I just wondering, when you generate those graphs and you generate from a certain data, right? That data within Neo4j, is it where's the data is? It's stored
So
in
memory. Yeah, the data is stored in memory. It is
and
a
it's like a sample data within that software.
so well, I mean we are the database, right? So we do actually store the data. Like you're actually storing it
I
in.
see.
Yeah, it's
So
like
you,
it's so
uh-huh.
different from relational. You're just like, I'm confused. There is I have some slides on how that digs a little bit further into the underlying technology,
Mm-hmm.
but honestly, I don't know how to dig into it too deeply. Let me see if there's something
Yeah,
like
yeah, I just wondering if they
it's a
if we
transactional
can
data.
connect outside the data. And so seems that we have to really put the data in that software, load in
Mhm,
there so we can generate, because we just wondering if we can see the relations, those data, because sometimes there's a lot of data we don't
mhm,
know their relations. If we can really generate graphs and we will know their relation, I think this
mhm.
tool is used for that.
Yeah, so Neo4j is transactional. It's a
Mm-hmm.
transactional database, and it's also ACID compliant. Um, so the benefit of that is like we're really big graph people. So one of the
Mm-hmm.
things that we try to avoid is that if you are using Neo4j as like your main database and you are, you have a transactional type of data, data coming in, we want to make sure that there's no nodes that are floating around with no relationships or no relationships that are pointing at nothing, things like that. So that's why we have it as like transactional ACID compliant. But it is a database. Generally, people do not put graphs on top of their tables because if you're traversing through like highly connected data sets, kind of like the one I showed before, I think I pulled it out. Like, but if you're like playing around with like these highly connected data sets, and the problem is that if it sits on top of tables and you're doing you know a lot of these hops, making connections, a lot of connections and a lot of hops, things are just going to start being really slow because every time you make a jump, what would normally be your join, you have to index every time. And every time you're indexing, that is very computationally expensive. So with
And
Neo4j, that's why when we store it, we try to store it with memory pointers rather than sitting it on top of tables. So just the underlying
mm-hmm.
architecture supports the graph data model rather than tables.
Oh, those connections, like those one bubble connect to another, that relation you created or they found themselves.
Well, you can create things where it like calculates it and then like it can add relationships based on specific actions or something like that. But it's a
Mm-hmm.
transactional data. So it would work very similarly to the way you would set up, another NoSQL database. If you're setting it up in a transactional database, it would work that same
Mm-hmm.
way, right? So if somebody makes an order, so you would have like a person makes an order, it would give you that
Mm-hmm.
full query. It would add that into the database.
And it can detect the relation itself, right? If you don't create it, and if it can find they are related, and it will draw a line itself, right?
I think so. I think it really kind of depends on how you build out your graph.
Oh,
But generally, I think it could do that. I can't speak too deeply again because
Okay.
not one
Okay,
part.
got you.
But yeah, I believe that it can.
Yeah.
Like if you have
And
one
so
individual.
from me, I just simply think we just take a look. We don't really put that in. I thought if it's possible, only
Yeah,
connect it, don't load the data in. We just take a look and just
yeah. So I
and we
mean, you could do that, right? Like you could put a graph on top of your tables, but again, like the problem is when you're working with highly connected data sets, every time you make a hop and you're indexing all the time, your performance is going to be
okay.
very, very slow.
Got you.
So now I did, there was a conference that I went to where I spoke to this guy. He came over to me and he told me that originally, when he had heard of these graph databases, and he was like, okay, there could be a use here for it somewhere and something that he's doing. He did something similar. He works for a very, very large enterprise company. He told me he took graphs and put it on top of his tables. And then he saw that the performance was horrible, but he realized that they did have a graph problem. And that's when they moved all the way to Neo4j. So we do have on like the Neo4j sandbox, there is a blank sandbox if you wanted to play around with it. So that's something you could always download Neo4j and just kind of try to set it up and see, what makes the most sense. But it's not necessarily just meant for visualization, right? You have like the ability to query and traverse through things quickly, and not having to index. Like the index-free adjacency is huge when you're talking about highly connected data sets.
Okay, thank you.
All right, Karin, we got another question for you.
Sure.
Paul, I have unmuted you. Would you like to go ahead and ask Karin yourself?
Sure. Really what I'm trying to do is find out, is the goal of a graph database to define your connections or your relations in the shortest path? I had gone to one demo where they talked about using a graph database to sort through connections and make it possible to, or easier, more rapid to go from point A to point B. It was an airline demo he gave.
Definitely.
He said that the connections wound up being something that you wouldn't think, because there are so many airlines going to so many cities through so many different hubs that it was difficult to just say this is point A is connected to point B, and they had to do some really weird stuff, and it got down to where they only had like 3 connections, and it just performed marvelously. And I was curious if that was, could you give me any idea of how best to model my relations?
Actually, that's a really, so the airline use case I think is probably one of my favorites, because like when you think about when you're thinking about graphs, like you look at an airline map and it looks like a graph, right?
Right.
And shortest path is probably one of like the quickest, easiest strengths of Neo4j. So like even if you're thinking in terms of like if you're creating a navigation tool, right? And you have every intersection is a node, and then the
Right.
relationship between those intersections can have values and those weights can change. And then if you're calculating shortest path, you could definitely do it that way. But there is a lot of capabilities with Cypher. Whoops. Let me see if there's like a Cypher ref card. So are you asking specifically about like what other types of things you'd be able to do?
Really what I'm looking for is what resources I could leverage in order to learn how to model my relationships. I'm brand new at this. I've got the third normal form down. I do it in my sleep. Finding the
Yeah,
relationships between, you know, like trying to go from Dallas to Prague. Well, how many different airlines can go there from Dallas direct, and how many can go there if I fly through JFK, and how about if I go through Newark, and what if I go through Atlanta, what if I go through Miami, you know?
Yeah,
So
or if you want to
it
go
just
through
it
Miami
really
or
gets,
Atlanta,
yeah,
what's the
it just
best thing to
really
go through there?
gets, it gets bizarre as to the number of relationships. And the guy that, I don't recall his name, but he said that, you know, once they got the relationships correct, that things just fell right into place, and they were able to figure out, okay, you want to go from Dallas to Prague, and bang, you can get there in three stops if you do this, two stops if you do this, or direct if you do this. And I was
Yeah.
just like, okay, that's
I know it's really cool. So one of the things I would say is like, so it really depends on what your data is, right, that you're working with,
right.
because generally you have to model your data model the way you want it to be, or whatever you might be asking of it. You know,
Okay.
there is what I would say is, let me see. I'm wondering if there's like modeling data Neo4j. Let me see if there's like, there should be some, okay, so data import and modeling with Neo4j. This might be a good place to start.
Okay.
But I would look into graph data modeling,
Okay.
because this is the type of stuff that you almost like, and this is what I was saying before, is like, you know, when you go from SQL, like there's things that you cannot do with SQL. You simply can't do it with SQL that you can do with graphs. And not only that, but like they perform exceptionally well. And
Right.
because like because the problems can almost, you have like these different sets of problems that you might have not had before. You know, like you were saying, like you could stop in Atlanta or Miami or both places, or you want to go here first and then go there, or what's the quickest way for you to stop in Miami, or should you stop on the way back or go over here or whatever. Like you can definitely do that kind of stuff in graphs. But data modeling in itself is like, it is a course you probably would want to dig in deeper. There's a lot of research, I mean a lot of resources about data modeling. I also think we have something under Graph Academy with
Okay.
Neo4j that helps with data modeling. Data modeling is a really good place to start too. Like if you've already decided that you have a graph problem, but I
I
think
haven't
there's,
decided I have a graph problem. I have decided I want to know graphs.
yeah. Um, so the sandbox I think would be a good place to start, honestly, because like the sandbox, there's so many different use cases here, and it's like pre-existing data sets. You don't need to know anything, you know.
Right.
So like you have, so like here's like a recommendation use case. So like I'm gonna start. I'll just jump into one of the sandboxes.
Okay.
So I don't know why it logs me in under colleague. My colleague Mark's name is like. So I'm gonna launch the. Oh, Bloom is like one of our visualization tools. So there is some really cool visualization too. Um, the graphics are, we actually have a meetup on Thursday, this coming Thursday. That should be a pretty interesting one. Um, that's going to kind of dig into some visualization stuff too. So this is our sandbox where we're, like I said, it's like there's just like, you don't have to download anything. There's pre-existing data sets. There's all kinds of different um, use cases. Like here, you can log into your own Twitter if you want to check who you tweeted at that didn't retweet you
Hmm.
or whatever. All right, so like I'm gonna launch the browser. So I really like this as a place to start because, oh, so he gives you like a little guide walkthrough, but you really, I'm not gonna show you this, but so here you have like different explanations. Oh, so this is an example of a movie graph. So similarly to the Tom Hanks thing I was showing earlier, you can actually skip through this. It talks about the data model, the introduction to Cypher. So if you were like, if you run a query, you can actually run a query here. And this whole thing will walk you through. This is a really, I think this is a really good place to start. Excuse me?
Sorry, I just unmuted somebody, and I guess that person's background is kind of noisy. So
Okay. But yeah, the sandbox might be a good place to start. Um, and the Graph Databases book, it's pretty good,
Okay.
and it helps you kind of. I don't know. I kind of say like if you start to see in graphs, like where you're like, wow, all these things are connected to each other. Like, what's dependent on what, or how are all these things related? If you find yourself seeing in graphs like that, then you might already be there.
Okay.
But there's definitely a lot to learn. There's a lot of stuff that you can do with Cypher. Like even though Cypher, it's a pretty clean, beautiful query language. Um, there's a lot of things that you're able to do with it. But the sandbox is great because like it just has guides that just walk you through everything, and you could just kind of play around with stuff and
Okay.
start to get an idea of like where graphs are used and how you can
Okay.
utilize them. But there's
All right.
so many different use cases. I'm telling you, like I've heard of some really crazy ways people use it. Like an example of one, actually, maybe I could even show it. There's a guy named Ward Cunningham. I don't know if you know him, but he's Ward Cunningham. Uh,
Old guy.
do you know who he is?
That might have been the guy that talked to me about um, the airline demo.
Oh, really?
Yeah.
Okay. Yeah, Ward Cunningham. He's amazing. He's the guy, he created the first wiki, which I think is crazy. I'm like, what kind of person creates the first wiki? So he created this project that so he works with New Relic, and he created this project called El Dorado that allows you to see all the different. Let me see. So let me see this.
Who's that first guy with the
I
headset on?
think he. Oh, that's Will Lyon.
Okay. That's who it was.
He's my colleague. Oh, this guy? Oh, that's
Yeah,
my colleague.
him. Okay. Well,
But what he did, what Ward did is he mapped out basically like all the projects that everyone was working on at his company, and what team was working on what, and who reported to who, and who was working with who. And he created this like basically, and there's like sources. I think there's like 37 different sources where you pulled in all like this project data. But it's basically a project management application that he built that's like super cool. Another organization I heard that used it, what they did is they had their human resources team map out all like this. They have it's a huge company with a lot of employees. So they mapped out all the different people, what teams they were working on, who they were working with, who they interacted with more. Now, I don't know exactly what they were looking for in all this data, but they were trying to identify people who were flight risk. So people who are likely to leave the company.
okay.
I know, it's crazy. I'm like, who even thinks of that? I don't know. Um, but yeah, I
Well,
mean, there's
HR, when you think about what is the cost of replacing an employee, it's well more than their salary. So,
hmm There's another organization, a similar like HR like type of approach, where they also like mapped out people's skills and the projects they were working on and all that kind of stuff. And they what they did is like they created a recommendation app. So if one person at the company leaves, what other people might have used similar skill sets or worked with similar people or collaborated with the same teams or worked on similar projects that could also be good for this role. So they were trying to like internally hire people that were fitted for the roles,
okay.
which I think is really interesting. So there's all these kind of like connected data problems that like you don't even think about, you know? Um, yeah,
Very
there's
cool.
a, there's
Thanks
a
for your
lot.
time, Karen.
Yeah, no problem. I hope you find some interesting use cases that you can play around with.
he
'Cause there's definitely a lot. Yeah.
Karin,
Yes.
when you mentioned the word Cunningham work,
Ward,
where's
yeah.
the website? Is there a website or is there a link?
So this is our community site. I can post this in the chat.
Oh,
Um, where is the, 1 second, sorry.
so
Where
that's
is
the
the,
link?
yeah, I'll post it right here. But this is on our community site. So we have like community.neo4j.com. If you go to community.neo4j.com, you can actually click on projects and look at like the different things that people built. You know, there's different kinds of projects. A lot of people, some people don't talk about the projects, some people do. And then there's also a content page too. So people post all kind of content about what they built. So here's like somebody put about finding influencers and communities, discovery and visualization of software vulnerabilities. That's an interesting one. So this guy has a Medium article that talks about how to find software vulnerabilities, which I think is really interesting. And here's the graph model. So this is a place where, like on the community site, people share all kinds of stuff and blog posts, and here he talks about how to install it in Neo4j, running it, installing plugins, GraphQL. Actually, now that I'm looking at this project, I'm like, I kind of want this for our online meetup. But yeah, there's a lot of people who are posting on all kinds of different projects and stuff.
Cool. What about that one you mentioned earlier, the cancer biologist one?
Oh, that's het.io. So this is actually the one I'm looking at right now.
Okay.
This is like where all like the different diseases and genetics.
Mm-hmm.
Yeah, you can actually, so it's het.io.
Oh, so they post their project over there?
Yeah, you could just launch the browser for free. It's all the data's open. Daniel Himmelstein is a big advocate for open data. Oh, oops, I just realized that I'm sending the messages to the organizers instead of the whole
Oh,
chat
that's
room.
okay. Yeah,
Oh,
I copied it over. I
thank you.
guess maybe that's the setting or something.
Oh, it's possible. Yeah, but this is het.io. This is the thing I was talking about that he does. But he's the one who put all that data in there that you can kind of play around with.
Would you be able to download the data?
I think so. I think he's got the data on GitHub. It's all open.
Oh, okay. Cool. All right. So you mentioned that Neo4j you have like a free download. Is that
Yeah,
more like
it's
a
open source.
community version?
Yeah, but the community version, because we have community, it's open source, and we have enterprise. But our community version is strong. I mean, I'll put it this way: NASA uses community. So,
Seriously.
yeah, I know, it's crazy, right? But
Wow.
I mean, it is what it is. I mean, we do have there's a lot of very, very large companies that use Neo4j enterprise, but most of them are like, your Walmarts and your AT&Ts and LinkedIn, and there's a bunch of companies that use. Every time I actually say about all the companies that use Neo4j for things, I just feel like I'm just name dropping, but it's true.
Okay.
I think it's 12, no, I think 75% of the top retailers in the world are using Neo4j for something. The majority of financial companies, big banks like JP Morgan and Citibank, and a lot of the big banks use Neo4j for things. But I think like probably the most common use cases are recommendation engines. So fraud detection is a big one. Recommendation engines, master data management. I mean, there's a lot of honestly, the things that I've heard about how people use graphs. I mean, there's a lot of like, you have your standard use cases, but sometimes the things that you have the capabilities of doing is like you don't even think of it until you have that kind of access to that type of data. So.
Okay. Would you be able to elaborate, what kind of cases you have to use Neo4j Enterprise, and when can you use just the free version? Of course, I understand that majority of the company would rather, if they could, they would rather use a free version.
Yeah, I mean, you're able to, let me see. So honestly, like, I mean, we have a lot of people who use our, so if you download Neo4j, that includes like Neo4j Enterprise for developers, I think. So, but you can download Neo4j and you can use it. Most of the enterprise companies that are using it are like, they're pretty large enterprise companies. I don't know the exact specifics of like what the differences are. I don't get too deep into like the sales side of things.
Okay.
But thinking like, I know that there's like some extra like backup features and some security things that are different. We also have a startup program. So if you have a startup company under 50 employees, you can have Neo4j Enterprise for free.
Wow.
Yeah.
50 or less?
Yeah, so the Neo4j startup program, yeah, so if you have less than 50 employees and $3 million in annual revenue, you're able to get Neo4j Enterprise for free.
Less than 3 million, less than or equal to 3 million revenue.
Yeah. Mm-hmm.
Okay. But when,
But honestly, depending on what you're doing, like our community version is very strong.
mhm.
There's a lot of people using it, so you know you may or may not need it. I don't know. It really kind of depends. There's a lot of companies that a lot of enterprise companies that if you work for an enterprise company and you're interested in using Neo4j, it wouldn't even surprise me if it's already approved and there are already people using it in different departments and teams.
Yeah.
Because like Neo4j's, let's see, Neo4j customers. Let's see. I don't know if they have all their listed, but like, you know, there's a lot of people who use Neo4j. It's pretty crazy.
Right. Well,
So
just I'm just curious, and when they use the Neo4j to analyze stuff, will they be able to use it to analyze why Bitcoin, say like the price go way up all of a sudden?
there's, you know, there's a guy. Oh, hold on. Let me see if I could find this. Neo4j online meetup, Bitcoin. There's a guy who did a really cool talk on Bitcoin. Where is it? Oh, it's this guy. Yeah, I think this guy's based in London. I host our oh yeah, token analysts. So they provide transparency for the decentralized economy, and they do like a lot of like blockchain and Bitcoin transaction stuff. So this is a really cool. I really enjoyed this online meetup where he was talking about like following the transaction patterns of Bitcoin. And so we have this one that's really cool. I'll put this in the chat.
Great. Yeah, I was gonna
And then
ask
we
you.
also have we have the XRP data, Neo4j. Let's see. We also have this one. So this one's another interesting Bitcoin one that is on XRP data, and this is where it kind of goes into visualization a little bit. But this is also another really good one. And this is GraphXR, the one I was talking about that was like, whoops. This is the visualization that some people will use. The visualizations all really depend on what you're doing with it, right? So I know that like you, for example, like you're a BI analyst, like you might enjoy using Bloom or GraphXR. But this is the visualization. This is GraphXR. So we have a meetup actually with them this coming week too, an online meetup. So like these different colors can represent like either it's sent transaction. So like this is has received or has sent. But the GraphXR graph is pretty cool. So this is all based off of Bitcoin data.
Wow.
I know, it gets crazy.
Yes. Wow. That is amazing.
Yeah, the visualizations get really fun. But this is when you get like, expansive. And this is also where you can start applying graph algorithms too, right? Like with the centrality and all that kind of stuff. That stuff can become really valuable also.
Oh boy.
Yeah, it's okay. You could get lost in the hole.
Yeah. All right. It's kind of late. Anybody else has questions? I remember. Okay. When I tried to unmute. When I just unmuted you, are you gonna? Do you have a question?
Yes, can you hear me?
Yes.
Yeah, oh, thank you. Great presentation, first of all, thank you.
Oh,
And
thank
my
you.
question is how to load the data to Neo4j? Is there any ETL tool?
Oh,
And
yeah, we have.
yeah, how to load data from SQL Server to Neo4j? Is it possible or is it directly?
Yes, no, it's absolutely possible. We are very like advanced technology. So I would honestly, I'm not going to dig too deep into it, but let's see, like you'll be able to get like SQL Server into Neo4j. I'm sure you could find. So here is like this one's probably a pretty good one. We have so many resources online because we've been doing this for so long. But yeah, there's ETL tools. Oh, this is old. I can tell. This is my director. But I mean, I could send you this one, but there's a lot of different sources. We have an ETL tool, and I mean, it's pretty easy. I mean, a lot of it's kind of translating what your relationships are and all that kind of stuff. We have a lot of material online that can really walk you through step by step. But we also have, let me see. So there should be, I think there's also some stuff too here. So this is like guide importing data and ETL. So,
oh, that's awesome.
yeah, so this is the developer guides. So
from a different resource, from different source.
Yeah, I mean, it's the same thing. It's all on neo4j.com, but this is our developer guides, and that can walk you through pretty much everything.
Yeah, that's very helpful. Yep, that's great. Thank you so much.
No problem.
Yeah, just FYI, whatever Karin posted to here, I reposted to all the audience, so you should be able to get it. Just at the chat window, get all the links that Karin shared.
Thank you.
Thank you so much, Karin, for staying on to answer all of our questions.
Honestly, I love graphs. I could talk about this stuff all day. So like
Yeah,
whenever I meet like other graph people, I'm like, oh my God, we just talk about how everything's connected and all the cool things you can do with it.
yes, that's really amazing. I really like your talk. You did a wonderful job to explain it and share all the information. That's just great. And I was kind of surprised you guys meet every week.
I know, it's a lot. I'm not the one who made that decision. I don't know why we do that.
Is that a local or it's a online event?
It's an online meetup. So you
Oh,
go
okay. Will we
online.
be able to join or?
Absolutely, yeah. We have here. I'll give you the online meetup. This is the link for the Neo4j online meetup.
When do you normally meet?
Every Thursday, usually Thursdays. So this is the next one. It's the 3D modeling, but I just sent you the link for the online meetup.
Oh, okay. What time? I didn't pay much
Usually
attention.
Eastern time, it's 11:30 a.m. on
Oh,
Thursdays, so like lunchtime.
oh, okay.
But it's also available afterwards too. So
Cool. Yeah, I just post that their online meetup in case somebody is interested to join them.
okay.
Okay, great. Thank you so much, Karin, again to present for us and stay on for this long to um, explain all explain and answer all the questions. Um,
Thanks
this
for having
session,
me.
yeah, this session is recorded and I will post it online on our YouTube channel tomorrow, application development channel.
Great, thank you.
Yeah. And then once you're ready, Karin, please send me the slides. I will post it on our website and then share with our audience.
Sounds good. Thank you, Sarah.
Great. Thank you so much again. And thanks everybody to join with us and hopefully you guys have a wonderful weekend.
Yeah, and if anybody wants to reach me, the community site on Neo4j is probably the best place.
Oh, yes, right.
Great.
Cool.
Thank you.
Thank you everybody. Thank you, Karin.
Bye.
Bye.